Okay, so the final exam is 50 questions, and today we're going to be looking at that final. So like I told you guys yesterday, the order of the final is going to go in the order that the objectives were presented to you. So, and here in the description, I have, all of the information, which questions are from which objective, all of that. So let's jump into it. The first part should be fairly easy. This is the part where we talked about, using your calculator or preferably learning the mental math, but using your calculator is okay to do the adding and subtracting integers. So here you guys can look at this. You can do this in your head or put it in your calculator, but the key answers are here. So this should be a quick review. So this was objective 1. So for number 1, if we put this in our calculator, -3 plus -5, I would recommend that you put the -5 in parentheses, or you can do this in your head. -3 plus -5, you're adding those negatives together, so you would get -8, okay? So hopefully everybody should be good with objective 1. For objective 1 through 5, 4 questions are going to those objectives, and the rest are going to be 3 questions. So for 5 through 8, we have objective 2, which was on multiplying and dividing. So hopefully you guys are good with this. Like I said, it's okay to use your calculator. All of this is building blocks from, where we ended up in objective 15. Then after that, in objective 3, we went into like dealing with the rational numbers. So that's, fractions, decimals, all of that. Of course, we cannot add or subtract fractions unless we have the same denominator. So here, if we look at number 9, we're asked to subtract these, but with this first fraction, we have a denominator of 4. And with the second one, we have a denominator of 24. So we would have to change the first fraction to have a denominator of 24. So if we change the first fraction, what would it be?
-18 over 24.
Okay, and how did you get that?
Multiply both by 6.
Yes, so 4 times 6 will give us 24, and whatever we do to the bottom, we have to do to the top. So that's how we got 18 over 24. From there, when you subtract a negative, you will be adding. So we're looking at -18 plus 13, and that's how we get -5 over 24. So with the decimals, of course, you can put that in your calculator. With the division, when we divide fractions, we multiply by the reciprocal. So this will become -12 over 11 times 9 over 8, okay? From there, when we just multiply, straight across. So it'd be -12 times 9 and 11 times 8. And when you reduce that, you'll get -27 over 22. All right. With exponents, we can also do that in the calculator, or we can just do is 9 to the 4th power. We can do 9 times 9 times 9 times 9, or we can put it in our calculator and use those correct functions to raise, 9 to the 4th power. Then we went into evaluating. And with evaluating, basically, we have an equation, right? And they're giving us what those variables are. So if we look at number 13, we have 2a minus c plus a squared, and they tell us what a, b, and c equal. So all we have to do is plug in the given value for a, b, and c. We plug that into the equation. Let's do one of these fraction ones since they might be a little difficult. So for number 14, we have 5ab over 8 minus 2cb. All right, so we got 5 times a. They tell us a equals 2 and b equals 4. Then that's over 8. Then we got minus 2 times c, which they tell us is negative 3, and times b, which is 4. All right. So the first thing I noticed is that 2 times 4 is 8, and I know that 8 over 8 is 1. So I would cancel this out and just have 5. That's what I would do. But if you need to do 5 times 2 times 4 and then divide that by 8, by all means, do that. So then we have negative 2 times negative 3, which is positive 6, times 4. So we'll have plus 24. So 5 plus 24, that's how we get the correct answer, which is 29. Okay. So same thing for number 15. Just plug those numbers in and just work it on out. So from there, we went into solving equations for a variable. Number 17, we're solving for x. Number 18, we're solving for b. Number 19, we're solving for x again, like that. So basically in these equations, you have only one variable present, and we have to do the opposite of certain operations to move those things to the other side. So here in number 17, we have x plus 5 equals 7. So to move this 5 to the other side, because our end goal is to have x equals whatever, but we can't have x equals with this 5 over here. So in order to get this to the other side, because it is plus 5, we have to subtract 5. So 5 minus 5, of course, is 0. That's what we wanted, so we can get the x by itself. And over this side, we have 7 minus 5, and that's what's going to give us 2. So the correct answer would be x equals 2. If we look at number 18, we got b minus 4. So we'll have to add 4 to both sides. So negative 4 plus 4, of course, 0. That's what we wanted. 13 plus 4 is 17. With 17 and 18, you do for 17, we subtracted 18, we added. For number 19, because the 5 is being multiplied by the x, you want to divide by 5 on both sides. So once again, doing that opposite of the operation. Divide by 5 on both sides. Negative 20 divided by 5 is negative 4. Boom, you got your answer. You ready to go. So for the final, the questions should be one by one. So if we're looking at 21, this is technically a 2-step. we want to get m by itself. So first we have to add 7 to both sides, and then we have to divide by 4 on both sides. If we look at number 22, we have to combine like terms, meaning take the 11z and subtract 7z. Then we will add 7 on both sides and then divide by whatever number is in front of that z. So that's how that works. All right. All right. So 21 starts objective 6. So objective 6 is 21, 22, and 23. So it's basically different variations of this type of problem, different ways that you will see it, where you have to combine the like terms in 21, or in 23, where both sides have an x and a constant, and then you have to move that over. So let's look at number 23. So for number 23, basically I would subtract 4x from both sides, and I would subtract 5 from both sides. So on the, and let me cross this out. So on the left side, I would have 4x, and on the right side, I would have 12. So x would be 3. Okay. So that's how you would do that. Let's look at objective 7. Objective 7, we got 24, 25, and 26. With these, it's basically the same thing we did in objective 6, but with fractions and parentheses. So with these, of course, we talked about, of course, you can do it with fractions, but it's easier if you find that LCM and get rid of the fractions. So let's take a look at that. So if we look at 24, our denominators, we have 3, 6, and 3. So we will want to get rid of that denominator. So the LCM of 3, 6, and 3 would be 6. So what we want to do is multiply everything by 6. So 6 times this first term, we'll have 6 times 2, which is 12, divided by 3, we'll have 4x. And then negative 5 over 6 times 6, we'll have negative 5. And negative 1/3 times 6 will be negative 2. So from here, it's a lot easier to work this. We add 5 to both sides, get 4x equals 3, divide by 4 on each side, and we get x equals 3 over 4. Okay? So I think canceling the denominator is a great method to work with, especially the problems where it's just each term got a fraction. So if we look at number 25, our denominator is 2, 3, and 4. So what is the number that we can multiply everything by for number 25?
12.
Yes, 12. So 12 times 1/2, that'd be 6. 12 times 2 over 3. 12 times 2 is 24 divided by 3, give us 8x. And 1/4 times 12 gives us 3. So from here, easy peasy. We got the 6. We can subtract 6 on both sides. So we have negative 8x equals negative 3. And when we divide both sides by negative 8, x equals positive 3 over 8. If we look at 26, we have this 2 in front of this x plus 1. So we have to do our distributive property where we take this 2 and multiply it by the x and by the 1. So we have 5x plus 2x plus 2 equals 23. Then from here, we just combine like terms, which will be 7x plus 2 equals 23. Then we will subtract 2 on both sides, and we'll have 7x equals 21. And from here, we see that x equals 3. All right. So that was objective 7. Let's move along. So in objective 8, which is 27 to 29, we talked about the inequalities. So over here, this will be positive infinity. And over here, this will be negative infinity. So I hope we didn't have that misconception. But let's look at number 27. Say write the solution in set builder notation. So we know that set builder notation looks like this. We write sets using these kind of brackets. So let's look at x minus 4 less than 1. So when we're working with inequalities, for majority of the time, we kind of create the inequality symbol as if it's an equal sign as far as how we move things across it. The difference comes in when we multiply and divide by a negative number. So of course we would add 4 to both sides. So we will get x less than 5. And remember, in our set notation, we write the x first, we do a bar, and then we write x less than 5, which is this first option up here. So when we graph it, and in WebAssign, the way that we graph this, we will put an open circle or a parenthesis. So let's do an open circle at 5, and that is closed. So let's do an open circle at 5. And let's shade it to the left. The same way that this arrow here, same way that this inequality sign looks, that's where we're going to shade, like that. Okay, so this is what I meant by you can use the parentheses as well. And it's negative infinity, comma 5. So if we look at this one, same situation. We just have that equal to. So it's x plus 3 greater than or equal to 1. Still subtract 3 from both sides. We get x greater than or equal to -2. And we find the set builder notation that mimics this. We have the x here in the bar and then this. And when we graph it, it's going to be a closed circle or a bracket. So we can have a bracket at -2 and shade it this way, or we can have a closed circle here and shade it that way. All right. For number 29, we just are dividing both sides by 2. So it'll be x less than or equal to 8. And of course, find the corresponding set builder notation for that. And graphing it, because it's less than or equal to, it'll be closed or a bracket at 8. And it'll shade to the left. All right. For 30 through 32, we talked about objective 9. Here we are basically evaluating again, but we talked about function. So here you will see the notation a little different. We have the f of x in number 30, which is saying that it's a function of x. So f is the function of x. So here where they say f of 9, they basically are saying that x equals 9, and they want us to plug that into the function. So same thing we did before with evaluating, just with a better understanding. So f of 9 means that we're plugging 9 in for that x, okay? If we look at 31, f of 3 means wherever we see an x at, we're plugging the 3. So we got 3 squared plus 2 times 3 minus 3. If we look at 32, we got h of 1. So that means that wherever we see that p, we have to plug in a 1. So we got 9 times 1, and 1 plus 8. Okay, let's keep on going. All right, 33 to 35 is on objective 10. So here we are graphing. In objective 10, one of the first things we talked about, which with graphing, we talked about 3 different ways. So we talked about the 3 points, which is basically finding 3 x's, plugging them in to find a y, and using those x and y coordinates, that input and output, to plot those 3 points. So that's the first way of graphing that we talked about to kind of get your feet wet. Then we went into the intercepts and all that kind of stuff, understanding about your x and y axis and finding what we call the x and y intercept, which is a point that's actually on that axis. Okay, so if we look at this graph, and of course this graph is the correct answer, but if we look at this graph right here where it meets along the x-axis at -2, this is x equals -2 as far as our x-axis. If we look at the -3 here on the y-axis, that means that our y-intercept is -3. So the x and y intercept is a point on the x and y axis, okay? So for this particular graph, if we were going to graph it with 3 points, so let's just say 2, 0, and -2. So y equals -3/2 times 2 minus 3. Y equals -3/2 times 0 minus 3, and y equals -3/2 times -2 minus 3. Okay. So if we look at the first one, 2/2 is 1. So we're looking at -3 minus 3, which equals -6. For the second one, anything times 0 is 0. So our answer is -3. And for the third one, once again, 2/2 is 1. And we have a negative times a negative, which is a positive. So we got +3 minus 3, which is 0. So these are our 3 points. 2, -6, 0, -3, and -2, 0. So in WebAssign, in order to plot a point, we have to hit this point, this little point icon. We find our points. We got 2, -6. So we go to from the origin 2, then down 6, and we plot this point here. 2, -6. Then we got 0, -3, which we don't have a x term, but we do have a y term. So this is a y-intercept. So it's a point on the y-axis at -3. Then we look at -2, 0. We don't have a y, we have an x, so that means that this point lies on the x-axis at -2, which is right here. Boom. Okay. Now that we have those points plotted, we click here on this double-ended arrow, and we want to make sure that the double-ended arrow is selected. So we select that so that it's dark, showing that it is selected. And then all we have to do is click on 2 of the points, and it's going to draw a line for us. So that is how we graph in WebAssign, okay? And that's it. This is the 3-point method, the picking 3 X's, the making a chart, all the different names y'all got for it, as long as y'all know how to do it, okay? Okay, what's another way that we could graph this? It's already in slope-intercept form, so we can use what we know about slope-intercept form to graph it. So -3 would be our y-intercept, so we'll just plot a point at -3, and then our slope is -3, 2. So from our point, we'll go down 1, 2, 3, and to the right 2 to find another point. And as you can see, if we did that in this situation and we connected them, we will also get the same graph of the same line, okay? So that is the 3-point method that we talked about, slope-intercept method, and we also talked about finding the x and y intercept. So let's look at one of those. So for this one, for number 34, it is in slope-intercept form. So the intercept is +3. So we could just plot a point at 3 here on the y-axis. And because the slope is -7, we can go down 7 and to the right 1. because it's -7 is the same thing as -7/1. Okay, so let's look at this one. Now, this one is interesting because, and we talked about this in class, these 3 different methods of graphing in different situations, some may be easier than others. So this one is indeed in AX plus BY = C form, okay? Which this situation is kind of ideal, I believe, for finding the X and Y intercept. But if we look at the numbers and if we think about, if we plug in a 0 here for Y, we're going to have 4x = -6, and we're going to have to divide both sides by 4, and that's going to give us a fraction. And graphing fractions is not ideal. So what I would recommend is to just change this and make it into slope-intercept form. So we have 4x plus y equals -6. In order for it to be in slope-intercept form, I need y equals mx plus b. So that means I need this y to be over here by itself. So this 4x is positive, so I'm going to subtract 4x from both sides. Then I will have y equals -4x minus 6, which is slope-intercept form. So with it in this form now, I know that my slope is -4/1 and my b is -6. So with that in mind, I can click on my little point icon, plot a point at -6 on the y-axis, and for my slope, I can go down 1, 2, 3, 4 and to the right 1 and put a point here. Click on my double-ended arrow, click, boom, boom, and we got a line that's correct, okay? But that's graphing in a nutshell. So we will end here today. We'll pick up with objective 11 for the final. And y'all have an awesome rest of y'all day.